Hello everyone, welcome to this video where we are going to explore congruent figures, and two figures are said to be congruent if they are of this same shape and size. So for this particular case, you will then have to write here, same shape and size. And this translates to mean that all corresponding angles and all corresponding sides are equal. So if triangle ABC is congruent to triangle PQR in this example here, where I will have A, B, and C corresponding to P, Q, and R. This means that now I'm going to color code it. Point A corresponds to point P. Point B corresponds to point Q. And point C corresponds to point R. And this does affect the way we write the size. Notice point A to B, AB. So I'm going to write P and Q. Same order. So point B, see the line is equal to Q R. And the sides A, C is equal to the side P R. As we move on to the other side of the angle, the corresponding angle is also the same. Okay, meaning angle A, B, C. Corresponding angle would be P, Q, R. So if I were to write angle BAC, this angle will be equals to angle Q, P, R. Notice how I write it. Alright, I always write it in such a way that the corresponding points are exactly the same. So another example, angle. Now the angle ACB, is then equals to angle P, R, Q. Okay, so the corresponding sides are exactly the same as how I write it, and therefore you can also write, if we say they are congruent to each other, there is also another way of writing it. We also can write it as, write triangle ABC is congruent. This sign means congruent to triangle P, Q, R. And at this point, it is important to note, which I will write at the side here, that we do need to write it such that the corresponding points are matched to each other in the same order. This means that this is wrong when I write triangle A, B, C is congruent to triangle BAC. Alright, this is not the correct way of presenting your statement. Do take note that the order must be matching, like A to P, B to Q, C to R. Hello everyone, for this part of the video we will then explore similar figures. They are identical in shape, but they are different in size, and this has implications on the corresponding length or sides or the angle. This means that all the corresponding angles are equal, but the corresponding sides are different, and they are actually in proportion to each other. So, for example, if I say that triangle ABC is similar to triangle EFD, the very first thing to take note is that we must always make sure that the corresponding sides are matching to each other. Then, let's work on the angles first, okay? The corresponding angles should be the same, and the way you write it must be also in order. So if I were to say BAC, angle BAC, then I do have to write it in, I need to start with F. I cannot start with D, because it must be in the same order, E, F, and D. Alright, so if I have angle ABC, then ABC, then the corresponding angle, they are the same. I cannot write DFE, I have to write EFD. Same goes for the last angle, they are the same. If I write as ACB, angle ACB, then I have to start with E, okay, instead of F. So it has to be E, D, F. Let's go over to the sides. Alright, so in this case, when we say that they are in proportion, it means that when I divide the corresponding sides, they must be of the same rate, increase in the same number of sides. Meaning, so if I have my E, F, dividing by my AB, notice how Mr. Tan write the sides. I also make sure that it is in order. Then this will be equals to 4 divided by 2, 2. And I check for the other two other sides. They should also be of the same proportion. Alright. So if I have B, C, and FD, so my FD divide by my B, C. 10 divided by 5, yep, it's the same number, 2. And last, if I would have my ED, dividing by my AC. Again, notice how Mr. Tan write the vertices, the points. They must be in order. Then I will have 6 over 3. Again, the proportion is the same. Alright. Then, they are similar to each other. Okay. So, a word of caution. Triangle. If you write triangle, this way of writing is wrong. A, B, C. If you write is similar to triangle F, E, D. This will not be correct. Alright. The points or vertices must be the same order. Alright. And let's move on to the next part where we will explore what we call the enlargement and reduction of a plane figure. Alright, let's explore what we call the enlargement and reduction of a plane figure. So when a plane is either enlarged or reduced, the corresponding angles. Oh, let's write it neatly. In the image are the same. This is important. The corresponding angles are the same. It's just that the corresponding sides of the image as compared with the original are in proportion. Okay, or are proportional. Both mean the same thing. And thus, the enlarged or reduced image is actually similar to the original figure. So the ratio of the side of the image to the corresponding side of the original figure, right, is called scale factor. Of either the enlargement or the reduction. And the next line will share with you the formula, okay? Where would have the scale factor is actually can be calculated by just having the length of the side of the image divided by the length of the corresponding side of the original figure. Okay, so in this case here, you would have noticed if it is going to be a reduced image, meaning reduction, the scale factor is between 0 and 1. Okay, less than 1, bigger than 0. But if it is going to be for enlargement, it will be greater than 1. Okay, so the scale factor actually does give us some indication whether the image is going to be reduced or enlarged. Let's move on for some work examples to illustrate this point. Hello everyone, welcome to this part of the video. So we are required to draw an enlargement of the following figure using scale factor of 3 over 2. 3 over 2 also can be written as 1.5. Okay, so since it is greater than 1, the figure will be an enlargement, which is rightly pointed out here. Okay, so I am going to have this slowly When I count here, this will be 10 small square. So 10 multiplied by 1.5. 10 times 1.5, that will be 15. So I will have 15 squares here for that side. Okay, so let me pull out a ruler and we will just start to draw it. So I will have 15. One, two, three, four, five, 15. Here. Alright, and let's move on. When I count, there are 20 small squares here. 20 times 1.5. So I would have 30 small square above. So that is what we are going to do by adjusting my ruler. And we are going to count and draw 30 squares, alright? So there will be 10 squares here, 20 and 30. Similarly for the other side, it will be 15 squares since the original have 10 square. Here will be 15. So let's continue to finish out this enlargement. And oops. If we have 5 square here, means that 5 times 1.5, that will give me 7.5. This side and this side is also 7.5. So using my ruler again, let's start to draw these two sides. 1, 2, 3, 4, 5, 6, 7.5. The other side as well. 1, 2, 3, 4, 5, 6, 7.5. And we are supposed to get to the middle part. Do take note that where is the middle part here. So actually I also counted. If here is about 5, that means I would then have to count right in the center here. I would then have to count until 7.5, yeah? 7.5 would then reach here. Okay, that means I should see a 7.5 such that this will be my final answer. Okay. And let's move on to the next example. Alright? Alright, next example, we would then have to draw a reduction. And it is indeed reduction because the scale factor is less than 1, 2/3. So we always start off by trying to calculate the number of length and get it to reduced. So in this case here, I would have 12 small square here. This translates to 12 times 2/3. I will have 8 square. Okay, that means the reduced length here, I'm going to just draw and make sure that I have 8 squares. So I will have 1, 2, 3, 4, 5, 6, 7, 8. And I stop there. So here I should have 8. So I've counted here 15 square. So meaning 15 times 2/3. I would then have 10 squares here. So I'm going to draw a line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Continue. On top is also 12. So on top will have to be 8 as well lah, huh? And we are reaching and finishing this reduction soon. And I have 6 here, as well as 6 square here. Oops, sorry. So 6 times 2/3 will be 4. Meaning that I will draw 4 square here and 4 square here. Okay. So let's go close. 1, 2, 3, 4. I stop. Below. 1, 2, 3, 4. I stop. Okay. Next would then be that I saw that here to here is 3 square, meaning 3 times 2/3. I would then have 2 square for the smaller image. That's why when I draw here, you would see Mr. Tan connecting here. The diagonal is only until 2. And of course I join that diagonal back up to the top. Okay, last but not least, I still have this 3 square here, or 3 times 2 over 3 is 2. And this happens at the point here. And at this point, right, I'm going to zoom in. You do see that this particular line is drawn where here is 1. So 1 times 2/3. Yep. And therefore you will see Mr. Tan here will start off with trying to find the position. And the position also here is 3. Means that 3 times 2/3. That position will be somewhere here. Okay. Where here is 2 over 3. And here is 2. And I'm going to draw the line now here. 2 here as well. I should reach here. And lastly, this will be the final answer, where I will have 2, 2, 2. And let's zoom back out so we can see the final product. Okay. And let's move on to the next example. Everyone, welcome to this example where we are given the length of a real, actual human eyeball. Okay, so this will be what we call the original. So this will be the original, okay? So I'm going to use a blue color. This will be the original. Okay, and the original is 24 mm. And we are going to make a model for it. Okay, and the model, we have a scale factor of 15, means that it will be an enlarged version, yeah? Because 15 is bigger than 1. So find the length of the model eyeball in centimeters. So all we have to do, given that we already know that the scale factor is equal to the length of the model over the length of the human, that means the length of model eyeball in this case over the length of the human, the actual one, the original one, eyeball, is equals to the scale factor. Then all we have to do, we could then just substitute the numbers in. Yeah, this will be the length of the human which we are given. We also given the scale factor, and therefore we could easily find the length of the model eyeball by simply multiplying 15 by 24, and this will give me a value of 360 millimeter. They want the answer in centimeter, so the conversion would then be to divide by 10. That will give me cm, 36 cm. And we are done with this example. Let's move on to the next example. Hello everyone. For this example, we are given a figure, and in the figure, right, they indicated that there is a reduction, alright, of a rectangle ABCD is reduced to rectangle EFGH, and we are supposed to find the value of P. So knowing reduction means that they are actually similar figures, yeah? And so the corresponding proportion, meaning A to B divided by EF, that proportion is the same as 9 divided by 3, BC divided by FG. And that is what we are going to tap on. So 4P minus 3 divided by 5 is going to be the same as 9 divided by 3, because they are reduced in the same proportion. Okay? And so with this, I would then be able to find the answer easily. Okay? I'm going to multiply by 15 on both sides, such that the next line you would see 3 multiplied by 4P minus 3, and this will be equals to 9. You also see 5 multiplied by my 9. Alright. And after which, then we can continue to solve this equation. The next step would then be to expand and simplify. I would have 12P negative 9 is equals to 45. And let's continue to solve this particular equation. I'm going to add 9 on both sides, such that I'm only left with 12P is equals to 54. And finally, I'm going to divide by 12 on both sides to give me the final answer for P. So my P will be equals to 4.5. And we have successfully come to the end of this video. If you like this video, do give it a thumbs up. Thank you for watching and have a nice day.